Myself, Dr. Nitin Kumar B. Patel from Sri Jayendrapuri Arts and Science College, Bharuch. Today, I shall discuss the topic on mass spectroscopy, the general theory and the fragmentation patterns of different classes of compound. Now, introduction of the mass spectroscopy. Spectroscopy in general associated with the electromagnetic radiations like as UV, IR, NMR. In mass spectroscopy, no such absorption of electromagnetic radiation, hence it is not true spectroscopy. However, mass spectrum is a plot of different peaks with their position m by z value taken along the abscissa and their relative intensities along the ordinate is called mass spectrum. Therefore, it is similar to other spectral studies like UV, IR, NMR, position and their intensity. So, here in this figure mass spectrum is shown, the mass spectrum of dodecan C12H26. So, different peak is there and different group of peak is there. So, different cluster of peaks is observed in the mass spectrum. When mass spectrum is plotted against m by value against percentage of relative abundance. So, group of peak is observed. So, different group having a so many number of peaks. So, it is a cluster of peaks and last cluster is a molecular ion group and from that molecular ion peak detected. Similarly, highest peak in the mass spectrum is known as base peak and from that we can get the information regarding the molecular structure of the compound. Now, what is the use of mass spectroscopy? What is studied by mass spectroscopy? Determination of accurate molecular weight. Accurate molecular weight is determined from mass spectroscopy. Fragmentation in organic molecules. Determination of structural features in organic compounds that we will discuss in details today. And third is determination of the molecular formula. And besides this, another use also there, like as latest recent application is GCMS. So, in GC the detector is used as a MS and it is combined technique GCMS. So, from this technique we can get the percentage purity of each compound, means compound having a 4 or 5 compound mixture, then one is major and other is impurity. So, impurity peak also giving mass spectra and molecular structure is determined without using the standard sample of impurity, and we can also deduce the unknown compound impurity from the GCMS technique. This is the recent development in the technology. So, GCMS technique is a combined technique, only GC giving purity, but without a standard we cannot give the purity of the compound. Now, next production of mass spectra. How mass spectra is produced? So, there are two methods, electron impact method and chemical ionization method, that is known as EI and CI method. Now, EI method is most frequently used. So, today we shall discuss in detail this EI techniques. So, in EI method, neutral organic molecule is bombarded with heavy beam of electron. So, neutral organic molecule is written here M, capital M, is bombarded with heavy beam of electron and one electron is removed. First of all, 8 to 13 electron volt radiation beam having 8 to 13 electron volt correspond to 185 to 300 kilocalorie per mole energy. So, one electron is removed and we get radical cation. As electron is removed, so this molecule is positively charged ion. So, all organic molecule is even electron system. So, in all organic compound there is even electron system. If one electron is removed, then it is odd electron system. So, one electron is removed, then positive charge is there and one electron is left. So, it is a radical cation. So, it is known as radical cation or molecular ion or parent ion. Now, this parent ion undergoes fragmentation, further fragmentation. So, intensity of the beam is raised from 13 to 70 electron volt. So, that corresponds to energy in kilocalorie per mole around about 1600 kilocalorie per mole. So, that molecular ion undergoes fragmentation, and only one electron is removed from the molecule. So, masses is not changed, that correspond to molecular weight of the compound. So, all radical cation or parent ion correspond to molecular weight of the organic compound. Now, that molecular ion further bombarded with intensity increases up to 70 electron volt. So, it undergoes fragmentation and mixture of ions with different m by z value comes, and that different ions on the magnetic field variation they are separated out. Higher m by z value come first, and then with increasing the magnetic field strength, low ions having a m by z value low comes later on. So, that is why a scan of spectrum from mass 1200 to 500, 12 to 500 performed in second. So, organic compound having a mass from 12 unit to 500 unit perform in seconds. So, this is the very few time is required for scanning the mass spectrum. Now, neutral organic molecule in a vapor form is introduced into the instrument, solid and liquid heated in a vacuum, and it is vaporized, and milligram to nanogram material is used here, and vapor pressure is kept up to 10 raised to minus 4 to 10 raised to minus 5 torr vapor pressure, 1 torr equal to 10 raised to minus 3 atmosphere, and then it will be electron, heavy beam of electron is impact in ion source region, and electron beam up to 70 electron volt. 1 electron volt equal to 23 kilocalorie per mole, and that neutral organic molecule in a vapor form, it is bombarded with heavy beam of electron. On impact of electron beam, molecule is sufficiently energized and produce a molecular ion, and then it will undergo fragmentation, and different fragment comes later on, and those having a high value m by z value is high, it is known as m by z or m by e, where z or e equal to charge. So, those fragment having a high m by z value comes first, and then on increasing the magnetic field, those ions having a low m by z value comes later. So, in general this reaction can be explained as follows: neutral organic molecule M in a gaseous form is bombarded with electron. So, it will remove one electron to produce molecular ion. Then further intensity of the beam is increases up to 70 electron volt. So, this parent ion is fragmented into M1 plus radical or M1 plus cation or M2 radical, or it may be M1 radical or M2 plus cation. Now, neutral particles produced in the process of fragmentation. So, neutral molecule or radical cannot be detected in the mass spectrometer. Now, after producing the parent ion or molecular ion in the source region, ion source, and after exit from the ion source, it will undergo fragmentation normally. So, all fragment accelerate with a kinetic energy, and all ion having a charge Z or E and potential is V volt, then it possesses a kinetic energy. Therefore, ZV equal to half mv square. This is equation number 1, where m is the mass of the fragment ion, Z is the charge, capital V is the voltage, and small v is the velocity of ions. So, now centripetal force equal to BZV equal to centrifugal force equal to mv square upon r. So, all fragment produced is travel through the analyzer tube, which is circular in part. So, centripetal force equal to centrifugal force. So, therefore, BZV equal to mv square upon r. Therefore, small v equal to BZR upon m. This is equation number 2, where B is the magnetic field, R is the radius of curvature, and now substituting the value of equation 2 into equation 1, we get ZV equal to half mv square equal to half m into bracket BZR upon m whole bracket square. Therefore, V equal to capital V equal to half B square R square Z by m. Therefore, m by Z equal to B square R square upon 2V. Now, radius of curvature is constant here, voltage also constant. So, this m by Z value depending upon the magnetic field variation. So, this equation governing by varying magnetic field, ions of different m by z are collected successively. M by z higher comes first. Now, this is the mass spectrometer. Here this is the ionization chamber, okay, and after ionization molecule on impact of electron beam, here gaseous sample is introduced from here, and then it will be impact heavy beam of electron and it will be produce molecular ion in the ion chamber. Then after exit from the ion source, it will undergoes fragmentation and accelerated through this analyzer tube, and then finally it is goes to the detector section. This is ion collector. So, mainly this instrument is consist of three part: ion source, then analyzer tube and ion collector. So, this analyzer tube, there is a magnetic field perpendicular to the plane of this paper, and this all ion fragment ion produced is accelerated through this analyzer tube, and finally that those ion only register, only cation is registered and neutral molecule and radical are not registered, and then finally it will be detected in the detector only fragment ion, and neutral molecule or free radical is not detected in the detector section, only cations is registered. That is why it will be goes to the detector region and it will be recorded, data will be recorded, and at different m by value they are plotted in the graph. Now, EI instrument, electron impact instrument. So, in EI instrument there are two type of instrument, single focusing only magnetic field is there, and double focusing instrument also there, which is composed of electric field as well as magnetic field, both are perpendicular to each other. Now, low resolution and high resolution spectrum is obtained. So, in low resolution, unit resolution accurately measure mass up to 1 unit. In high resolution spectrum, measures mass up to 4 decimal point accurately. If the molecule under bombardment is a molecule of ammonia, so ammonia molecule fragmentation is shown here. So, ammonia molecule is bombarded with heavy beam of electron, then one electron is removed from the ammonia molecule and molecular ion is produced. So, here it will be shown by this reaction. So, ammonia molecule is impact over heavy beam of electron and one electron is removed. It is shown by this equation, and it will produce radical cation NH3 radical cation. The molecular ion can eject a hydrogen atom and produce the cation NH2 plus. This is shown in second reaction. So, NH2 plus is produced by removal of H radical. This NH2 cation can then lose a hydrogen atom to produce NH plus, which can lead in turn to N plus. So, second reaction, third reaction is shown, NH2 plus loses H radical again and we get NH plus ion cation. Now, this cation NH plus further losing H radical and we get N cation. This is shown in this reaction. Now, the mass spectrometer then sort these cations on the basis of their mass to the charge ratio or m by z ratio or m by E ratio. Since for all practical purpose the charge on the all of the ions is +1, this amount to sorting them on the basis of their mass. Now, this is the mass spectrum of ammonia. So, in the mass spectrum of ammonia we see peaks at m by E 14, 15, 16 and 17, which is shown in this table 14, 15, 16, 17 and 18, and this is the mass spectra of ammonia. So, here this is the m by E value and this is the relative abundance in terms of intensity. So, here 14, 15, 16, 17 and 18 peak is there in the mass spectrum of ammonia, and fragmentation pattern is shown in this equation. So, ammonia molecule is bombarded with heavy beam of electron. So, one electron is removing and NH3 radical cation is produced. This is molecular ion correspond to M by E value 17, it is written here. Now, this molecular ion losing H radical to produce NH2 plus ion correspond to M by Z value 16, and then further removal of another H radical, it will produce NH radical cation M by Z value 15, and then further this NH radical cation loses H radical to produce N14 plus N plus M by Z value 14. So, this is the mass spectrum. Now, P correspond to 18 mass unit. Now, 17 molecular ion having a M by Z value 17, this correspond to molecular weight of ammonia molecule. Now, peak above 17, that is 18, is a M plus 1 peak, that is called isotope peak. So, all ions of ammonia under fragmentation, then all ion will be, by convention we express NH3 radical cation as NH3 bracket radical cation, and it is written like this. Similarly, NH2 plus is written like this. Similarly, NH plus is written in general like this, and N plus is written in like this. The small peak that occurs at M by E in the bar graph, this peak is labeled as M plus plus 1 to indicate that one mass unit greater than the molecular ion. The M plus 1 peak appears in the spectrum because most element nitrogen and hydrogen have more than one naturally occurring isotope, and although most of the ammonia molecule in a sample of ammonia are composed of nitrogen 14 and hydrogen 1, means hydrogen element natural isotope. A small but detectable fraction of molecule are composed of nitrogen 14, 1 hydrogen and 2 deuterium atom, this is isotope. These molecules are nitrogen 15 and 3 H1 or nitrogen 14, 1, 2 hydrogen, 1 atomic mass 1 and 1 hydrogen having a deuterium as a deuterium. So, produce molecular ion at M by 18, that is M plus 1 peak. Now, M plus 1 element is carbon, hydrogen and nitrogen, because one mass unit higher